Hi, welcome to this session, which will cover the topics and the themes of consumer behavior. What makes consumer behavior that we observe in society be what it is? So in this particular chapter, we will focus on the two different dimensions in the simplest possible model called the utility theory model of consumer preferences. One aspect of this model consists of looking at the satisfaction or the pleasure or the benefits that one individual would receive from being a part of an economy as a consumer. And we refer to those benefits or the satisfaction as utility. It incorporates emotions, sensations, as well as comparative mechanisms that enable us to understand trade-offs based on opportunity costs. And it also enables us to rationalize decision-making and compromises made by consumers. We will also look at the second dimension of this exercise, and that dimension consists of the budget constraint, which is the resource limitations that consumers are subjected to whenever they make decisions about what they are going to consume. As we know, we don't have unlimited resources. We don't have unlimited amounts of time or unlimited amount of trading resources to affect just about anything we want. So we can't get everything we want, and the budget constraint is how we model what we can afford to get as consumers when we are looking to buy or make decisions about purchasing a good or a service in an economy. So those are the two different concepts that get combined into a metric. So we will start with a utility function. A utility function is a mathematical construct that assigns a numeric value to the benefit or gain obtained from consuming certain goods and services. So in this example that you see here in the slideshow, we have an example where Sarah receives a utility of 3 units for every mac and cheese sheets, 2 units of utility for every unit of broccoli, and 8 units of utility for every ice cream. So if she consumes a bundle of goods that consists of 1 serving of mac and cheese, 2 servings of broccoli, and 2 servings of ice cream, her total utility would multiply these amounts of 1, 2, and 2 units of each by the 3, 2, and 8 units of utility per item, totaling a total utility of 23. So if we look at here at this calculation, if we move now to a different situation that is a little bit more realistic, we're going to assume that goods confer a positive utility to a rational consumer. We're going to look at a model that makes that condition or assumption. The other one is we're going to look at a 2-good economy. We're going to call these goods X and Y for simplicity. And we're also going to assume that goods confer a diminishing rate of utility to a rational consumer. And we call this an application of the law of diminishing returns, which means that every time you consume 1 more unit, the total utility conferred by that extra unit is less than the previous unit. Imagine you just ordered a pizza, you're super hungry, you get the pizza delivered, it's still hot in the box, you open the box, the wonderful steam and aroma of the pizza comes out, you get even hungrier, you pick that first pizza and you eat the first bite of the first slice, and it evokes all kinds of wonderful feelings and sensations. It gives you great utility to have had that bite. As you complete your first slice and move on to the second slice, you start feeling full. So this time that you pick up the second slice, by the time you pick up the second slice and start eating it, there's less utility conferred than the first slice provided you with. By then, the aroma has been lingering in the room that you're eating. You're back to thinking about all the other things except how hungry you are. And this enables you to feel satisfaction, but not as much satisfaction as before. So that's what we mean by a diminishing rate of utility. So if I were to look at this in a graphical setting, I would have one dimension called X. I would have a second dimension called Y. One in which, as you move away from the origin, you have more of X and more of Y. And so that origin is where the star is located. That's the baseline. And at that point, you have a third dimension. And in this third dimension, we're measuring utility. The utility based on consuming X and Y. That's a third dimension. Okay. So if you looked at the angle between any two of these three axes, every one of those angles is 90 degrees. So there's a 90-degree between the purple axis and the x-axis, between the purple axis and the y-axis, and also between the x and the y-axis. Okay, so there's kind of like a little cube that we can build here. This is meant to be a right angle. This is another right angle. And this is another right angle. So there's three right angles in that intersection. And the way utility increases is the more X we have. So if we move around the plane between utility and X, the more utility, but at a diminishing rate. So notice how this line is going up, but it's going up at an ever decreasing angle. If we do a trace of the plane between utility and Y, the same thing happens. Utility keeps increasing, but at a decreasing rate. And if we were to create a plane, and this plane cuts through the data, if we create a plane at a certain height of utility, okay, so this is at a level of utility with respect to X, and then we have another angle which is at a level of utility with respect to Y. And I'm making this a plane, which is like a sheet of paper or a sheet of cardboard that I am okay, that's called a plane. And this plane creates a cut. On this surface, on this purple surface. And because the surface is curved and not linear, the cut that is made is also curved. So where the plane cuts the purple surface or sheet, that's where we have a particular trace. If I had a flashlight over here, and I was able to flash the light at an elevation above the line, pardon this god-awful flashlight that I just drew here, the light would shine through this translucent purple surface, and in a two-dimension rendering of this particular item, this would look as follows. This would be the variable x. This would be the variable y. And this would be the green, the shadow of the green item that I just traced would look like that. So this particular trace that I just drew where the check mark is would be consistent with this cut that I just made there. It would be the reflection down below here. And that trace is called an indifference curve. It's called an indifference curve because all the points along that trace offer the consumer the same level of utility, but at different levels of consumption of X and Y. So this is called a utility indifference curve. And just like I drew that utility indifference curve, I could imagine the trace of a higher level of utility, and that would be a trace that would occur at a place where you have more utility. So I'm going to call the first utility curve U1, and the second one I'll call it U2. And U2, the points on the red indifference curve are points that offer the individual higher levels of utility. Okay, so all the bundles of consumption along U2 bundles have a greater utility than U1 bundles. Okay. So again, let me feature this trace in 2 dimensions now onto 3 dimensions. So that would be the equivalent of U2 as opposed to U1. And if I were to pull back that trace onto the specific part of the sheet here, that would be where the actual level curve would be for U2. And notice that that would have to be created by a much higher level of utility, a plane that cuts this particular the utility function at a higher level. There you go. So more utility requires more of both goods, or so much more of one good than the other that you end up at this higher point of utility. And so now I can move from this three-dimensional drawing to a two-dimensional drawing version of it, as long as I know that these equal height lines, or utility indifference curves, or ISO utility levels, are such that they can't cross. It's impossible for them to cross, because then you would have equal utility and unequal utility at both cases, and that would be a contradiction of how utility increases, which is more is better, more gives you more utility, but at a diminishing rate. So these curves are essentially, these indifference curves are never touching each other. They're parallel to each other in this two-dimensional projection within X and Y. Okay. So we can talk about different bundles of consumption, like where these hearts are. I could label these points of consumption. I can call them point A, B, C, D, and E. And then the question is, which bundle offers what level of utility to the individual represented by these preferences. And obviously, we would prefer E and D over A or B or C. So that's purely a preferential mechanism of identifying consumer desires, consumer preferences. So the utility theory model is one that allows us to gauge and to measure what people want. Not what people ultimately decide to buy, but what people want to buy, and in what way they would like to trade off one good for another, which is partly a decision of their desires and preferences. So that's what these indifference curves allow us to do. Okay. The second dimension of a consumer behavior model is one that takes into account what people can afford. Okay, so question number 2 that a theory of consumer behavior must tackle with is, what can the consumer afford? Unlike the first question, which is, what does the consumer want? What does the consumer want? And the answer to this second question is not utility, but something that we call the budget constraint. And it's referred to as a constraint because it is a depiction of scarcity, of what it is that we can versus cannot afford about the goods. So for example, we're going to need pieces of information here about the consumer. We're going to need to know the income disposable to the consumer. So we're going to call this the disposable income. I'm going to set disposable income numerically already at a quantity. Let's say that you have a disposable income of 100 units. And then I also need a price for X, and I also need a price for Y. I need a price for each of the two goods, X and Y. And I'm going to actually get a number. I'm going to use the number, something easily divisible into 100 would be easier, so I'm going to use 10 and 20. So good Y is twice as expensive to buy in a competitive market than good X is. So I need that information in order to build a budget constraint. So these are called my given information. This has to be given. And so how do I build a budget constraint? Essentially, a budget constraint is a line, a linear function that measures how much I can spend on the X and Y, and my income limitation, my disposable income. That's what a budget constraint is. So in order to build this budget constraint, I need some base information on the context in which this consumer is operating. And it must be the case that for me to afford a good, afford a certain bundle of X and Y, what the bundle costs must be less than or equals to the income disposable. I can't spend more than I have. That's what this boils down to. So the generic formula is I'm going to be multiplying the price of X times the quantity of X, and that's going to give me my expenditure total in X. And I need to add to that the price of Y times the quantity of Y, and that must be a total of less than or equals to the income level. And in this particular case, then, I need to multiply 10 times the quantity of X and add that to 20 times the quantity of Y. And that must be less than or equals to 100 total units of income. As you can see, this is also a construct that fits in our two-dimensional model that we started building in red on the first whiteboard. So I'm going to go back to the color red, and I'm going to go back to building a vertical along with a horizontal axis. I'm going to use X again on the vertical axis. I'm going to use Y again on the horizontal. And then I'm going to draw a line that cuts into both axes. And this line is going to be called the budget constraint. And I'll draw it in green, the color of money, so to speak. And I'll notice that the most I can buy of X is 10 units, and the most I can buy of Y is 5 units. Because if I spent all my money on Y, I would be able to buy 5 units of Y, because 5 units at $20 a piece is $100. And the most I would be able to buy of X is 10 units, because 10 units at $10 a piece is also $100. And everything within that green line closer to the origin would be feasible, would be what I can afford. Okay, so this shaded region in green is what we call the budget set, or the feasible budget set. It consists of all the different points of consumption that are affordable, and the stuff that is beyond that is unfortunately not affordable. So all these data points, all these bundles of X and Y that are beyond the green line are not affordable. And then all the points within, all the budget points within where these check marks are, inclusive of points right on the line itself, all those points are called affordable. Another word that we employ sometimes to describe the check marks are feasible consumption bundles, and the red X's would be called infeasible or not feasible for purposes of decision making. So in the end, decisions made by consumers are essentially a sandwich of these two X and Y plots. So here we have X, here we have Y, two goods being consumed. The green line is what we call the budget constraint. And then we have a collection of levels of utility. This is one level of utility. Here's another level of utility. And here's another level of utility. And these purple lines cannot touch each other because they are different levels of utility. So I'm going to call them U1, U2, and U3. The special line being, the special indifference curve being U2, because U2 touches this green line at one and only one location, which is where the star and the heart are. And that's called the point of utility maximization. Why is that the point of utility maximization? Well, it's the point that is affordable. So it's on the green line, feasible in consumption, and also it is the point at which no higher level of utility is attainable due to the budget constraint being the shape it is. And so that is how consumers, according to this theory introduced in your chapter 7, That's how consumers make use of their preferences and their budget constraint together in order to arrive at a decision that is rational, that leads to the highest possible level of utility given the budget present, given the budget that is feasible in spending on X and Y. What kinds of things can lead to consumers changing the amount of X and the amount of Y they consume ultimately? So notice how this data point where the heart is has two different locations, one for X and one for Y. So this dictates the optimal amount of consumption of X and Y. Well, since there were three different things that we assumed to make this model happen, or three conditions in affordability. One was the level of income, disposable. The other one was price of X. The other one was the price of Y. Since these three factors can change, all three can bring about changes in consumer behavior regarding the purchase of X and Y. So what, if anything, is the impact of a change in income? Disposable. The way we would visually observe these changes in income would be as follows. Here's the first dimension of the graph and the second, X and Y, respectively. And I'm going to illustrate an increase in income. An increase in income would have the effect of having more resources available to purchase X and to purchase Y. So if the budget constraint originally looks like this, what would happen is that we would see more income, enabling the consumer to buy more X and more Y. And since the price of X and the price of Y haven't changed, because we're only changing one thing at a time, all else being the same, ceteris paribus, we will end up with a parallel shift outward of the budget constraint. And what that does is it expands the possibilities of consumption by all these points in the orange zone. So things become more bundles of consumption become available as choices to the consumer. So an increase in income causes a parallel shift right to the budget constraint, and more bundles become affordable. And I'm going to use the orange highlight to symbolically represent the greater bundle affordability. What does a decrease in income do? Exactly the opposite, the reverse. A drop in income creates a shift to the left, a parallel shift of the budget constraint to the left, and it reduces the bundles of goods available for consumption. How about a change in the price of X? So we're going to go and look at a change in the price of X. Specifically, we're going to look at an increase in the price of X. And as you can imagine, an increase in the price of X will cause X to become less affordable in absolute terms with respect to the income level that is being held constant. And in relative terms to Y. Because in order for you to buy more, to buy the same amount of X or to buy less of X, you would have to be sacrificing even more of the other good in order to maintain the affordability balance. So in this case, X is in the vertical axis, Y is in the horizontal axis. The initial budget constraint is in green. And I'm increasing the price of X. So what that does is it reduces the affordability, but only in the vertical dimension. So an increase in the price of X makes X less affordable. And what that means is that the budget constraint swivels in. So it's as if there were a hinge at the point where the budget constraint meets the y-axis, and there's a swivel in, and then there's a loss of affordability. So there's an income effect, but there's also a substitution effect that will happen in terms of preferences. There's two kinds of impacts that reduce the options that are feasible by the red area. So I'm going to put a bunch of X's on top of the less word so that we understand that those bundles are no longer affordable in that situation. You could also have a change in the horizontal axis price. Okay. So I'm going to create a third graph where we're looking at a change in the price of Y. And specifically, we're going to look at a decrease in the price of Y. And what that causes is more options, more affordability of Y in absolute as well as relative terms to the consumption of X. So that particular situation will provide us with a visual of feasibility. Such that the hinging is an outward swivel where now the hinge is on the x-axis and not on the y-axis. And what we see is a swiveling outward like that. And we have greater affordability. So instead of having X's, we have checks, because we now have more bundles that are feasible than before. And because we have more bundles, we are able to achieve or attain higher levels of utility as a result of that. So I'm going to put check marks on top of the word more to symbolically represent an expansion of feasible bundles of consumption of X and Y. So that is the impact of the three kinds of variable changes: the price of the own good, the price of other good, and the level of income. All have effects on these particular decisions by the consumer with respect to buying X and Y, bundles of goods and services of X and Y. That's essentially the main ideas that are presented in this chapter, in chapter 7. So as you see, as you go through the PowerPoint slides, you will see some examples of utility, of the concept of diminishing marginal utility, of maximizing utility subject to the affordability constraint, and how the budget constraint can determine when things are not feasible based on budget and feasible. And based on the different levels of utility, which bundle of consumption of two goods is A, feasible, and B, maximizes the utility of a person. Furthermore, how does income affect? How does price affect these decisions? Price of an own good and price of an alternate good. I hope that this particular video is helpful to you in working through and understanding the concepts in Chapter 7. Thank you for watching.